Okay, so I'm just share my screen. Which screen am I using now? Is it this one? Okay, Python class. Okay, can you see my screen now?
Yes.
Okay, that's
Yes.
fine. Okay, that's fine. So if you look at that, we stopped at this point. I've created 3 equations now, which we're going to test. We have passed this side. So we're trying to look at to use the general formula, which we normally call quadratic equation. I mean quadratic formula rather, to get this done. So and the formula is minus b plus or minus, just to refresh your memory, I'm sure you also know it, minus b plus or minus square root b squared minus 4ac all over 2a. So which means the plus or minus is telling us we're going to get 2 roots, 2 answers. We're going to get the root for positive, we're going to get the root for negative. So that's what I have done here. The name I was trying to remember the other time when I was expressing this, it's a discriminant. If you look at this discriminant there is the b squared minus 4ac. It's common to both the positive and the negative one. So let's sort this out first. Our discriminant will be our b star star 2, which is b squared, minus 4 times a times c. We already have our a and c here. So when you are running this code, you're not going to run this one alone. You are going to select this one. If you don't run from here and you just ask it to run here, it will tell you I do not know what you're talking about. A is not found, B is not found. So you have to, the system must understand that there is a value called A, B, C before you introduce this. So if you have written this, let's move on. We are still going to come back to run it. We don't want to see the answer yet. Because at the end of the day, what we want to see is to see the 2 roots at the end of the day. So root 1 now, which is the positive side, is now equal to our question, which is minus b plus square root of the discriminant. Sure, you remember that, because we didn't want to model it up. That's why we decided to write discriminant separately, the equation for discriminant separately. You can write so many things together. In fact, we can even say, what do we call it? We can even say, even this one ordinarily, we are supposed to say root 1 numerator and then the denominator, because we can use another approach to get this done. In fact, that is going to be your assignment. Look for another approach apart from what I have done here to implement quadratic equation yourself. You know, you're going to use another approach. That's going to be your assignment after today. So let me quickly give you an hint. You can do this top separately and then bring a denominator. You can say denominator is denominator. Denominator is equal to just 2a, 2 star a, 2 star a. And then you can then remove it here. Remove this 2 star here and then put denominator. You know, you can also do that. So in the alternative, let's say we already have it there like that. What you have done is you have said that minus b squared, discriminant all over 2a. Because this is minus b, okay, this is the square root of discriminant, which is there as it is. So our root 2 is the second answer, is the minus side. So minus b minus the same thing all over 2a. That's the only difference. And then before you know it, we have 2 answers. We have 2 answers. So let me run it from this point to this point. Why am I running from this point to this point? I've keyed in. Okay, let's start from the first one. Okay, I have 265. 265. I think let me use this last one. 2, no, not 2. This is 1. The coefficient here is 1. I'm using equation 3 now. The coefficient here will be 1. The coefficient of x will be minus 5 for b. Yes, minus 5. And I think the coefficient for it's minus 5. The coefficient for c will be plus 6. So that is that. So we're just going to run this with this. If we run up to this point, it will run it, but that's not where we're going. We still want it up to this point, even though that's not the final. You can see that there's no error here. No error is generated. It's telling us this is successfully run in 0 seconds. So, but then the answer is still within the memory of the computer. Ordinarily, if you want to see the answer, we'll just say root 1 will give us the first answer, and root 2 will give us the second answer. So let's print that out. You see it on the console here. Oh, okay, don't worry. I think it's running everything together because I formatted it. I formatted it in such a way that it can present it it can speak to us. Python works like a natural language. The way you speak to it is the same way to respond to you. So what I'm going to do here is I've already introduced them what we call string here as well. String are characters that you put in quotation, in double quotes, yes. Open quotes and closed quotes. That's a string. This is a function. Print is a function in Python, which is a function that you can call to print to the screen for you, not to print to your printer, but to print to your screen. And what is it going to print? It's going to print at first. It's going to print this thing in quotation. Whatever you put in quotation mark, when you write invoke print, you are going to get the same thing back the same way without mixing words. So if you look at this, just print this for me. It's going to generate this what we have inside that quotation. It's not going to print the quotation mark with it, the quotation marks with it. It's just going to print the content of the quotation mark. If you look at this place, we have used the colon here. It's going to print that colon as well with it. But that's not all. What we really want to print is to print the two answers. We want to print the root and root 1. I want to print the root 2. Now, in a way where you can combine it together in a string. Somebody is making noise behind the scene. Please help us mute your system. Okay. So what we're saying is this is another format for print. Now there is this F. I can't remember what they call this F. But then just note that once you put this F in front, it means you want to print some calculated variables. You want to output some calculated variables along with your string. So what is the calculated variable here? Who can tell us what the calculated variable is in this place that I've just highlighted? Normally your calculated variable is not good. It's not expected. Thank you, root 1. It's not expected to come with it's not expected to come in your string, in the quotes. But once you have F in front of it, that F will override that principle. You put F, and then whatever you now put in between your roots, whenever you put your root 1, which is your variable that is already calculated somewhere, you must ensure that you put it in curly brackets. If you look at that brackets very well, it's different from what do we call it? It's different from normal open and close brackets. It's also different from angular brackets. This is curly brackets. So you have to put your variable, which is an output somewhere, put it inside your curly brackets, and format your string whichever way you want to format it. Now what this is going to tell us is that it's going to print this as going to say root 1 dot, then put the answer. I won't put this root 1. It will go and fetch what the answer is in root 1 and display. And that's why we have this. Can you see this? The first print is giving us 2 real and distinct solutions. The second print statement is telling us is printing root 1. That one has to be printed as it is, and then bring the answer from root 1 because it's in curly brackets and displayed to us, which is 3.0. The same thing is what happened here to the third line of our print, which is giving us root 2. Let's put is equal to. Let's see what the difference will be. Is equal to. I'm just putting is equal to. Where is equal to again? I just pressed it down. Okay, is equal to. So you will find out that it's not going to bring that dot again. It's going to give us the answer is equal to. So let me run again. Let me select this and run again. Can you see the answer has changed? And then if I just say 2 real number, let me say the answer to the 2 quadratic equation is as follows. So this is just your coordinate, this is your word. So let's print it and let's see what we're going to have. Can you see? The answer to the 2 quadratic equation is as follows. You can see it's giving us as we have quoted it in the quote, and then it's bringing the print here for root 1 as that. and it's doing the same thing here. So another thing I want to do, you can, let's try for the second equation. Let's try another. So if you have this one now and you deploy it anywhere, whether online, it means anybody can have access to your, what do you call it? Have access to your package and begin to use. But then in this case, they won't be able to come into your code because they don't have access to your code. You have make it, you have done it like an executable file on your, or a package rather, a software on the internet, for example, on the web. So they won't have access to your backend. So it will be difficult for them to come back and write and change these values. Like I want to change for the second equation. The second equation is 2. The coefficient here is 1, it's still 1. And then I'm looking at this. The B is 6. It's positive 6. And our C is negative 5. Negative 5. So let's run that and let's see what the answer is going to be. I'm going to go back to what I was going to discuss. Okay, let's run that. Yeah, you can see that our answer is different. This is root 1 is 0.74, root 2 is minus 6.74. That's fine. So which means it can work for any quadratic equation that we have supplied the inputs. So it's also better, it's also possible because somebody who don't have access to your backend. So what you have to tell them is to be asking them to key the values in from the console, as in from the keyboard. Just let them prompt them to key in the value, you know, the values for A, values for B, values for C, rather than this. So I'm going to replace that. I'm going to replace that with this. Replace all these guys. I'm going to replace them now with this. Like it's a floating point. I want them to input number, first number. The first number they want to input, all of these things, whatever is happening on this right-hand side, it will store it in the left-hand side, which is our A. So what we are saying with this right-hand side is that we want you to catch a floating point and then let them input. Input is to ask number from the console, to ask for anything from the console. So it's going to display this to the user to understand what, this will be the prompt, you know, to understand, so that you can understand what the system is asking you to do. This one will say enter A, which is the first number, which is, you know, the first coefficient. Then you can also do the same and say, because you need for 3, let's say B, this will be enter B, as in the coefficient of B. This will now be the coefficient of C. So that way, the system will keep those values, will accept it from the keyboard, and will keep those values in the memory, and will use it to solve this equation. So let's see what we're going to have. Can you say enter A? So what's our A? Okay, let's look at do we do the third equation again? Our A now is 1. Our B is minus 5, and our C is 6. Our A is what? What's our A? Are you with me?
Our A is 1.
Our A is 1. Thank you. Press 1 and you press enter. Our B is what? Our B is 6.
Minus
6. Which one are you taking? Is it second one or the first one?
Second one.
Okay,
So
second. Yeah, our B will be 6. Our C will be what? Our C will be
minus 5.
Minus 5. Fantastic. So minus 5, you just press enter. There you go. You have the answer. Can you see? So I want somebody to give me a figure from your end. You know, ABC from your end, and let's key it in here. So if you look at this, you can see it has done it. It has accepted that figure and it's saying, you know, it's prompting me to enter A, I put the value, enter B, I put the value, enter C, I put the value. So let me run it again. I want to supply any figure from your end. Okay, 2 seconds, I will attend to you. Okay, it's already waiting for us. Enter A, what do we put? I think, do we do, somebody giving us a figure? What should be our A? Do I take 5? If it's not big, if it's not too big, I press enter. What will be our B? Let's say 4. And our C, let's say 7. Oh, Stack Overflow, domain error. So this is an error. It has generated an error, which means maybe it has generated a complex number. So that's another part we're supposed to check. We call it unit test. We have not done that. That's not part of the beginning. I mean, there are some things you are supposed to do when you are writing your code. You have to bring in all kinds of data to ensure that your system will not crash by the time you launch it. So as it is now, that figure has generated a complex number. That's why it's giving us error. That's why it's giving us error. So we're going to run it. And then if you type simple numbers, you will find out, you will agree with me that not that the program is having error, but it's only that, can you see, it's still running. But the value we have generated, I mean, we have inputted, it shows that at the end of the day, when it's doing the calculation, it's a complex number. And we have not given a command to check for that at the beginning, so that will not complicate it from the beginning. So let's hear you, Mr. Femi.
Thank you very much. So I was the part in which you just did now that you were saying enter, where we have a float input, enter A and B and C. It is not really clear to me. Can we say this part is the function in which, as we are entering those arguments directly, then it's going to return the final output?
And that's what it's doing. This is not a function. We have not created any function here as it is. Any function you have used, that you have seen that we have used here, it's an internal function of Python itself. We have not created our own function. No. And if you look at this float is a function which is internal, and it's local to Python itself. Input itself is also a function which is local to Python itself. What we have just done is simple. That's what I have explained. All the function we have written, all the codes we have written on this right-hand side here, whatever the output here on this right-hand side, the system is going to throw it to the left-hand side. And what do we have on the left-hand side?
A, B, and C.
So the value that this is going to get at the end of the day, all the things I've written here are just to prompt the computer or to prompt the user to enter a given value. And that's what has happened here. So if you look at this is the right way to do it. You will say input, and then when you are writing any function you type in Python or R, open and close brackets must be there. Can you see that? So if you look at the internal bracket that we have used here, if you look at this first bracket after input, it's because input is a function. That's why we have open and close. Do you get it? I put input. Once you type a function in Python or R, that's what you're going to get. So input is a function. Float also is another function, which must have an open and close. But in this case, you have to put the open here and close it at the back for float. Do you get? But what we want to do now is we want to enter a figure inside that input, which is open, is a string. We want to say enter a value A. That is what we have done. Have you seen it? Do you understand it now?
Yes, I understand it. That means at the end we need to put a space.
At the end, what do you mean by space? Here.
No, after the column, you put space. Okay, so that once the person enter those values to separate.
If you like, you can do it. If you do it like this, it will put that space, all of that space.
Okay, it's clear now. Thank you very much, sir.
You're welcome. So, but don't forget, you have to put the answer inside a container, which is our hey. That's what we want to fetch. That's the way we have generated that. That's the way we have generated that. So we can comment this out or we can erase it. Do you get that now? So it's as simple as that. Any other question here? Any other question here? I believe we all understand this. We understand it, and then I'm giving us an assignment to go and do it in another. Then let me also tell you, I'm sure you know that ChatGPT can generate codes for you. It can generate codes for you. But the thing is, when ChatGPT generates codes for you, if you don't have the basic understanding of all of these things, it will be difficult for you to understand how to manipulate it, because it is not 100% right most of the time or some of the time. So, and then even when you want to do some other things, how will you be able to go about it if you don't have the understanding of how it is done? So I'm going to show you how to use ChatGPT to generate this code. That way, it can facilitate your work when you want to build even large software, large projects. You can do it in bits, understand it, and then know how to connect the dots together. That's why it is important for you to have this understanding of how to use what and where. That's why we're doing all of it. Because ordinarily we could say, oh, just go and generate it in ChatGPT. But when you generate 1 million lines in ChatGPT, but do you understand what it does? So these are the things. So I'm going to show you ChatGPT can generate any code for you. Also, BARD can also do the same. BARD, B-A-R-D. BARD is a Google, is the competitor that is competing with what do we call it? ChatGPT, which is Google was created by Google. BARD.com. You can also get that done there. Now, the beauty of BARD is that BARD can give you a kind of a sample output of your code. That's the difference. But ChatGPT is more intelligent when it has to do with anything than the BARD. BARD is still just try to follow. So, but let me demonstrate to us. Let me just say, just go to your charts. I'm sure if you are not connected to my YouTube channel, you can do that now. We have done so many things with ChatGPT that you can do with ChatGPT. You'll be amazed to see that you can even begin to generate business with some of the things we have said there. There's a particular video that is talking about what you can do online, using all of these ChatGPT tools to get it done. All of those things, they are there. So you can check it out. It's a Akada virtual lab. I'm sure if you are part of people that are connected with us online, you can do that. So using ChatGPT, what you need to know is you need to know how to create your prompt appropriately, know how to configure it. In this case, I'm going to say, write a simple, let me remove this guy. 2 seconds. Write a simple code to calculate or to solve quadratic equation in Python. You can specify JavaScript. You can specify HTML. You can specify C#, anything whatsoever. But in this case, what we want to do is we want it to be written in Python. So let's see what we're going to have. There you go. 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 Can you imagine? Can you imagine? It has done it. It's also using our own formula. Import math, like I said, you have to import math because you need square roots. Square roots, SQRT will be fetched from import R. So if you look at this, it has done it. It has done it. It has done it. But then this is pushing it forward by putting the checks in case what do you call it? A complex number is generated. It has done it. It has done it. It has done it. It has done it. I can say rewrite in another way. ChatGPT will obey you, will rewrite in another way. It will do the same thing for you, but then in a different format. So the one I say you should do, don't go and use ChatGPT to format it. Think about it yourself and see what you can do with it. Or in the alternative, you can pick another equation, another thing of your choice. See, it's thinking about it and it has brought it. So see, is it finding a function to solve the equation. The man that is talking about function, this is the function you wanted to see. So is making everything to come inside solve quadratic. Is declaring it like a function. So the first thing is going to do still, it's a discriminant calculation. And then to also check for if it's positive or negative, it's putting the condition to check that. And this is else if it's not that, you move to this and do this. Else, this is complex. This is more complex. This is more cumbersome, but then it's still achieving the same thing. It's calculating the same thing, it's getting the same thing. So this is what you can do. You can do the same with BARD and you get your answer and you are good to go. So I think we are on top of the hour. Like I promised, I said we're not going to spend more than 1 hour, and I think we're about 10, 12 minutes beyond the hour now. So do you have any question at this point? Or is there anything you want to share with us? Or what other things would you like us to do? We are trying to, make it simple from the beginning now, from known to unknown, so that we'll not assume that we all know what to do and things like that. We don't want it to get complicated. That's why we have picked it from scratch. And that's what we have today. So, anything? Any question, any contribution, any comments? All right, in the absence of no. All right, somebody talking?
Yes, thank you very much for for everything so far. I think I was able to get you, but I want to ask, using Google Colab, and I know it's connected to our Google account.
Yes.
Okay, what about if you are working in a very big project, and in which that project we are doing a lot of complex analysis on the Google Colab, and we are importing our data sets that is very large, in which the final output is going to take a lot of space. Is there any downside since the Google Colab is connected directly to our Gmail?
No, Google Colab, you can import it here. Can you see where I've clicked? This is where you're going to bring in your data set from this folder.
No, I mean in terms of the final output. Is there any downside in which maybe let's say the output is, going to take the size normally in R, there are some model in which we want to build, and that model might take the entire RAM. If we don't have enough RAM on our computer, it's going to go slow.
It's an advantage because you can trust now that Google Colab, Google Cloud, they have unlimited space. That's another beauty.
Okay.
That's another beauty because it's not using the processor of your computer on your local system. No, it is using the processor of the cloud of their system in the what do you call it, in their machine, on their machine that is connected in a big network. So you have an advantage because there are some most of the time when you are running some complex equations or complex whatever in Python, they are memory intensive. That even your local computer will not be able to take it in a quick time. So that's why they have given you to an extent to be able to run that. But at some point, depending on what you are running, you may have to be thinking of renting the cloud space to be able to do a few other things. Do you get? But before you begin to think of renting out a cloud space, at least you must have used what is provided for you in Google Cloud to an extent. So it's as simple as that. So for me, that's the benefit, because as it is now, if I close this one now and I get back home on my bed, I don't need to save anything. I will just come back here again and be running it on my phone. Normally, even where there is NEPA lights or no NEPA lights, I am running my code, my Python code on my phone. That's the beauty. That's why I love it so much. Then the problem of setting up environment, setting up everything in Python in my local system, I don't have to do that. So I hope I'm not canvassing for Google products now. But it's free. It's to our benefit. It's to our benefit. So let's just take the advantage. But the only thing is, whatever you are doing here, they have access to it. So don't think that it's not safe. It's not safe. But then there's nothing we're hiding. There's nothing we're hiding. But anytime you want to generate anything that that at the end of the day you want to, like Flutter Wave, for example. I don't explain that Flutter Wave will deploy their new package, or maybe their new software they intend to put out in the near future. I don't expect that they will run the entire thing on a platform like this. So that caution has to be there. Because that's the beauty. That's what these people are using all of these things for. They're just making it available for us for free. But then they know where they're getting the money from. They have all our information. The same thing as our Google Mail, our Yahoo Mail, everything about Nigeria, about Africa, about the whole world, they have access to it. They have access to everything. And that's what we call digital hegemony. I have a preprint paper on that online. If you type Michael Awule and then you look for, what do we call it now? Digital sovereignty. Yeah. You will see some of my thoughts on that. You know, I have a preprint on a paper like that. So that's why a number of countries now are now coming up to say, wait a minute, let us challenge the United States. Germany is talking about it. Brazil is talking about it. China, they're talking about it. That because all the root servers for networking, they pass through United States. So if you're sending anything between my office here and my next door, it will first of all go to the root server, pass through the root server in the United States before sending it back to Nigeria to my next door neighbor. And why is that? It's going to have a stamp, you know, what we call it now, a footprint. It's going to leave a footprint on their root server. Everything, whatever you have sent, you know, they have access to that. But that's not the discussion for today. So any more questions before we round up and say thank you for coming? All right, in the absence of no, I say thank you for coming. I think we are good to go. It's a good time today. Sorry that initially we didn't start on time. It was because of that itch, but we quite appreciate everyone that is there today. Thank you, and God bless. Have a nice rest. Don't forget to go to our YouTube channel to have a look at the videos that may be of interest to you. We have about 62 videos there now, which may be of interest to you. So the name is Akada Virtual Lab. Just type that in YouTube. You can have access to that and you'll be fine. Thank you. Bye. Bye-bye. Thank you. Cheers.